Hello everybody, welcome back to OR1 with me, Ferry Afrinaldi. And on this video, we will discuss the revised simplex method, and all the materials that I have on this video are based on the textbook Linear Programming and Network Flows published by Wiley, and the lead author of the textbook is Mokhtar S. Bazara. The revised simplex method, it is basically the same as the regular simplex method. We follow the same step-by-step procedure, but we just use a smaller array. So when you implement the revised simplex method using a computer, then you can save the storage space. As you can see on the screen, this is the table that we will use in running the revised simplex method. And you can see that the size of the table is smaller than the size of the table of the regular simplex method. And here it is the step-by-step procedure and all the equations that we will use in order to run the revised simplex method. So we will combine the matrix operation with the operation using the table of the revised simplex method. I will explain how the revised simplex method works by using this example. And this example, you can also find it in the textbook. So the first step that we need to do in order to run the revised simplex method is by converting this problem into a standard format. So we need to add slack variables. So we will have x7 as our first slack variable, and this sign will change into equal sign, and we will have x8 as our second slack variables, and the sign over here will change into equal sign, and our last slack variables is x9, and the change and the sign over here will change into the equal sign, and all the slack variable x7, x8 and x9, they are non-negative. So I will not write down the standard format of the problem, but I will directly use Microsoft Excel in order to explain how the revised simplex method works. So in the Excel, I will use, we have 9 variables. So we have x1, x2, x3 and so on until x9. So they are including the slack variable. So in total we have 9. So we have j from 1, 2, 3, 4, 5, 6, 7, 8, 9. So j is the index for our variable. And then after that we need to have cj. The cj is the coefficient of the cost coefficient of the jth variable. So if we come back to the problem, so c1 equal minus 1, c2 equal minus 2 and c3 equal 1. So c1 is the coefficient of x1, c2 is the coefficient of x2 and so on. So here we will have minus 1, minus 2, 1, minus 1, minus 4 and 2. And of course the coefficient of x7, x8 and x9 are 0, 0 and 0. And after that we also need to have aj. So aj, that is the coefficient of the variable in the constraint. So the column A1 will be 1, 2 and 0. The column A2 will be 1, minus 1 and 0. It is 1, 2 and 0. A2, that will be 1, minus 1 and 0. A3, 1 minus 2 and 1, 1 minus 2 and 1. A4, 1, 1 and 1, 1, 1 and 1. A5, 1, 0 and 2, 1, 0 and 2. A6, that will be 1, 0 and 1, 1, 0 and 1. And x7, of course, there will be 1, 0 and 0, 0, 1 and 0, 0, 0 and 1. As usual, at the beginning, the slack variable will form the identity matrix. So after that, the thing that we need to do is to set up the revised simplex table. So we need to have here, we need to come back to the table. So basis inverse, basis inverse. So because we have 3 constraints, so the matrix over here will be, the basis inverse matrix will be a 3 by 3 matrix. So we'll have Z as usual over there, and our initial basic will be our slack variable, and therefore that is x7, x8 and x9. And this is a 3 by 3 matrix. Okay. And we'll have the right hand side over here, and we need to form the table. Oops, sorry. Okay, so this is our initial table, but it is still a blank table. So if you see in the algorithm of the revised simplex method, so the W, this is the location of the W in the table, and this is the equation for W. So since because B is an identity matrix, so and your CB, which is the cost coefficient of the basic variable, and you see that your basic variable is x7, x8 and x9, so it's CB, our CB is 0, 0 and 0. So when 0, 0 and 0 times B inverse, which is the identity matrix, so you will have over here 0, 0 and 0. Now because your basic variable is x7, x8 and x9, and it formed the identity matrix, so the basic inverse will also be the identity matrix, because the inverse of an identity matrix is an identity matrix also. Okay, so I'm just gonna copy it down. Okay, Now your right hand side, so see the equation of for the right hand side, this is CB B bar. And what is the B bar? Your B bar is B inverse B, and that's your B bar. Since now our B inverse is an identity matrix, so therefore our B bar is the identity matrix times B, and the B without bar is the right hand side of the problem, which is 6, 4, and 4. So B inverse times 6, 4, and 4, so it is still 6, 4, and 4. So here you have 6, 4, and 4. Now for the right hand side cell CB B bar, so we have our B bar, but our CB is 0, 0, and 0. Why? See here, this is your basic right now, x7, x8, and x9, and therefore and we have our the coefficient of x7 is 0 in the objective function equation. X8, its coefficient is also 0, and x9, its coefficient is also 0. So our CB is 0, 0, and 0. So 0, 0, 0 times B bar, which is this guy, 6, 4, and 4, and you will get 0. So that is your that is our initial table. Now the next thing that we need to do, the next thing that we need to do is to run the algorithm. So now we're gonna go to step number 2. We need to calculate, we have W already, and we need to calculate this Z sub j minus C sub j. The Z sub j minus the C sub j, it is just basically the rate of change of your objective function value in respect to the change of the variables. So in order to calculate Z sub j minus C sub j, I need this value over here. I'm just gonna copy it down. Okay. And in order to calculate the Zj minus Cj, we need W times Aj. So we have the W over here, and we have our Aj. This is A1, this is A2, and this is A3. So I'm just gonna put Waj, and this is a matrix multiplication. So our W is a row vector. It is a 1 by 3 matrix, and our Aj, it is a column vector with 3 rows. So a 1 by 3 matrix times a 3 by 1 matrix, it is a 1 by 1 matrix, which is just a number. So this is how we do matrix multiplication in Excel. So M mu. So where is W? This is our W, comma, times A1. So that's WA1. Okay. So I'm gonna lock the column of the W. So when I copy it down, it will not move. So you need to press Control, Shift, and Enter. So it will give you the number. So WA1 is 0. So we need to copy it down. Okay. So all the number of Waj is 0. Now, the next thing that we need to do, we need to calculate the Zj minus Cj. Zj minus Cj. And that is the Waj minus Cj. So, Waj minus Cj. So, just copy and paste. Now, when all the value of Zj minus Cj are 0 or negative, then the problem is optimal. But here, in this step, not all the value of Zj minus Cj are 0 or negative. So we need to continue. So as you can see, the maximum value of Zj minus Cj is 4. And that relates to x5. Okay. So x5 will be our entering variable. So now we have x5 as our entering variable, and of course we need to find our leaving variable also. In order to find our leaving variable, so we need to calculate the B inverse AK, where AK in this step will be A5 because our entering variable is x5. So we need to calculate B inverse A5. Okay. We have our B inverse over here, and we have our A5 over here. So a 3 by 3 matrix times a 3 by 1 matrix, so that will be a 3 by 1 matrix. So we need to do M mu. So B inverse times A5. Control Shift Enter. Okay. So 1, 0, and 2 will be our Y5. So the thing that I will do is I will copy it down over here. Okay. Starting from the Zj minus Cj plus the Y5 column. And the next thing that I will do, I will do the minimum test ratio. So we are in step number 3 right now. Okay, so this is the equation for the minimum test ratio. So we need to get the ratio between the right hand side value and the column of Y5. Okay, so here we have 0. So as you know, no need to do 4 minus 0. Okay, so what is the minimum value between 6 and 2? It is 2. So 2 relates to x9. So x9 will be our leaving variable. So the next thing that we need to do is to update our table. So if we go to the algorithm, so it's a update B by replacing AB with AK and return to step 1. So we need to update our table. Okay, so I'm just gonna copy the table that we have over here. Okay, I will delete all the value. So x9 will leave basis and x5 enters basis. So x9, so x5 replace x9. So we have x5 over here. So we need to make this number to be 1 So what to do that? We will divide it by 2, so or by itself. So everything over here in the x9 row or in the x5 row in our updated table, we need to divide everything by 2. Okay, so we will do 4 divided by 2. Okay, I need to lock the number 2, and then now I can paste. So this is the row of x5. Now the next step is that we need to find the value for the other cell. So in order to do that, we need to do the row operation. So for this we will do, so so that will be equal its original value minus uh, the value over here 2 times the value that we have when we do B inverse A5, and for this is number 4. So you need to put dollar over here and you need to put dollar over here. So when you copy it down, it will not move. So as you can see, this operation, it is still the same as the uh, operation that we do in the simplex method. So enter. So we just copy and paste. Okay. So this is the updated simplex revised simplex table that we have now. So what is the next step? We do the same thing as we did in the previous step. So we will calculate WAJ and then we will calculate ZJ minus CJ. So I'm just gonna copy everything down. Okay, not everything. So I'm just gonna do, I will pass it. So see, now I'm gonna check if I do copy and paste correctly. So okay, see here our WAJ. I'm gonna click this equation. So this is our new W and this is A1, so this is correct. Okay, so this is correct, this is W, this is A2, so this is correct. So this is the Z1 minus C1, which is correct. So this is the Z2 minus C2, which is the WA2 minus C2, which is correct. So so this is the red column is from the previous step, so I will get rid of it. So here we need to find the highest value or the most positive value of ZJ minus CJ, which is the, okay, it is x2. So x2 will be your entering variable. So the next thing that we need to do is to find our leaving variable. So as usual, the thing that we need to do, we do mu B inverse. This is your B inverse times A2. Control Shift Enter. So this is it. So we need to copy everything that we have over there to the table that we have. Okay. Now we need to do the minimum test ratio. So here it is -1 and 0. So it is the only positive value that we have, 1. So x7 will be our leaving variable. So x2 will replace x7. So now we need to update the table. Okay, so x2 replace x7, so x2 over here. Okay, so we need to, so this is our pivoting cell number one, so we need to we need to make it one. It is one already, so we need to divide everything in x7 row with number one or one, so it will be itself. But still I'm gonna do it. So 4 divided by 1. Okay, so it will be itself, and then we will do the same thing. So we will update the table, so we'll do the original value minus 4 times the pivoting cell, this one. So I need to put dollar over here. Oh, sorry, dollar over here and dollar over here. Okay. Okay, that is the updated table. And next, the next step that we need to do is to find the zj minus cj. Okay. Copy and paste, and we paste it now. So the thing that we need to check now, okay, so wa1 is a1 times w, it is w times a1, so it is correct. And w times a3, it is w, our new w times a3, so this is correct. So I think everything is right. I need to clear the color. So see, the zj minus cj, all of them are 0 or negative, so we can stop here because we already find the optimal solution. So the value of our z star is minus 16, and oh sorry, that should be minus 16, and the value of x1 star, x2 star, x3 star, x4 star. So x1 will be 0, it is non-basis, x2 0, x3 0, x4 0, x5 star, that's equal to x6 star, that's equal 0, x7 star, that equals 0, x8 star, that equal let me see, 8, and x9 star, that equals that equal what, 0. So this is the optimal solution. So as you can see that the revised simplex method, it is easier than the regular simplex method when you implement it using a computer. So final, if you want to check whether your calculation is correct or no, so one of the things that you need to do is that to check whether the coefficient of this zj minus cj are correct. So see here, so we know that x2 is our basis, so the value of z2 minus c2 is 0, so that's correct because it must be 0. xa is also basis, so see here, so it's za minus cs is 0 also, so that's correct. And then x5 is basis, so the value of z5 minus c5 is also 0, so we are good. So you can do this, you can check this in every step that that you do in performing the revised simplex method. I think that is all. Thank you very much.